Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we think we've got a timely topic for you today. Here it is. Building a scheduler using time and date compare functions. Okay, I know. Time and date, timely, pretty corny. But after over 120 live streams over the past 2.5 years, we're going to get a little corny on this channel from time to time. Okay, but seriously, today we've got a topic we've never covered before. Time and date compare functions. And those are critical when you're building scheduling capability into your machine. And today we're also going to show you how you could build a scheduler for your machine. Now this week, I am flying solo because we're pre-recording, so no Casey Gardner. But rest assured, Casey should be back next week for next week's topic. All right, let's take a look at how we're breaking down today's topic. Okay, we'll start by answering the question, what are time and date compare functions? We'll do a quick review of the OCS real-time clock, and then we'll talk about what is a scheduler function and what are some of the key components of a scheduler that you should consider when you design one for your application. And of course, we'll have demonstrations throughout. All right, here we go. What are time and date compare functions? Well, time and date compare functions are native instructions in Cscape, which are used to compare the current OCS real-time clock value with some preset set points. Now, they're often used in applications like lighting control, building automation, and others, where time and date are a key component of the control strategy. Now, there are 5 time and date compare functions available, and you can find them in the time and date operations section of the project toolbox. You've got time of day, days of week, month of year, days of month, and year. Those 5 functions are available. Now, how do they work? Well, each compare function is configured with a set of criteria. So it could be a specific time or date. It could be a specific range of times or dates. And if the criteria that's been configured for that particular function block through a variable or through a fixed configuration, if that matches, then the function block passes power flow. So as you can imagine, you can gang together or series together multiple function blocks to establish a more specific time and date criteria for controlling a specific output or a machine function. Now, let's take a look at the individual function blocks themselves. All right, let's start with time of day function. The time of day function specifies a start time and an end time in 24-hour format. Now, you can either hard code the times, as I've shown on the screen there, or more likely, you can assign variables or registers to those particular start times and end times. And of course, then you can vary them from the touchscreen or through another means in the application. Let's talk about days of week next. So the way this works is that each day of the week, and of course there are 7, is assigned to a bit in a 16-bit variable. So that means the lower 7 bits are effectively used. Now, when you want to have a power flow from a day of the week type function block, you're going to, in that variable that's assigned to that function block, you're going to turn a bit on for every day of the week in which you want power to flow. And of course, you can also hard code it as well. You don't have to assign a variable or a register, and that's true pretty much with all these function blocks. Next, let's talk about the month of year function. Now, the month function operates similarly to the day of the week, in that you have 1 bit assigned to a 16-bit variable for each month. So that would be the lower 12 bits, of course. And for every month in which you want power flow to occur, you would turn on that appropriate bit. Next, let's talk about days of the month. So again, very similar. You're seeing a theme here where you have 1 bit assigned to a variable. Now, in this case, though, because there are 31 potential days of the month, you need a double integer variable to be assigned for this function. But again, for every day of the month that you want to pass power flow, you're going to make sure that appropriate bit is set. All right. Lastly, let's talk about the year function. Now, the year also requires a double integer type variable to be assigned to it, if you're not hard coding it, that is, where the lower word is used for the start year and the upper word is used for the end year. And of course, you can also hard code like you can with all these variables. Now let's do a quick review of the real-time calendar clock capability in the OCS before we do a quick demonstration of those time and date compare functions that we've just reviewed. All right, so the way the real-time clock is incorporated in the OCS, there are a series of system registers that are assigned for that purpose, and you can see them listed on the screen there. So you've got second, minute, hour, date, month, year, and day, okay? And you can see the way that they're encoded on the screen as well. Now, some other things that can be useful in the OCS when you have a project, one thing that I'd like to review with you is the time and date graphical object, or the time data graphical object. And you can see from the graphic editor, from the list of icons at the top of the screen, you can see I've highlighted the icon for the time data graphical object. And that's the object you're going to use to display either the time or the date. And you have your choice of a whole variety of different time and date formats. You can show it down to the second or just down to the minute. You can show, a variety of different ways of displaying date, month, year with a 2-digit year or a 4-digit year with the date shown in front of the month or vice versa. However you'd like to do that, you've got a variety of different options. Now, when you're actually assigning a variable to a time or a date type display on the screen, if you're trying to display time, then the variable you should reference is SR44, which is the real-time clock second. So that's the first of the 3 time-related system registers. Now, if you're looking to display the date instead in that object, then you're going to reference the first of the 3 date system registers, which happens to be SR47, which is RTC date. Now let's take a quick look at those time and date functions in action. Let's fire up Cscape here, and I've got my simple demo program to show off these time and date compare functions. All right, so first of all, in the toolbox, they are available here, okay? Under time and date operations, you can see the 5 functions that we've just talked about a minute ago. All right, now let's see them in action. All right, let's start with the time of day function. So I'll double click on it here. And as I mentioned earlier, you can either hard code the time, start time and end time, or you can assign variables or registers for that purpose. Now, in all my demos for this simple demonstration here, I'm showing you the times and dates hard coded. But in the scheduler that I built as a demonstration that I'll show you later, everything uses variables instead. So you'll get to see both of those approaches. All right, so we've got what we've hard coded into this particular function is a start time of 0730 and an end time of 1930. So note that that's military time or 24-hour time, depending on how you want to refer to that. Okay, so if the current value of the real-time clock is between those 2 levels, we're going to pass power flow. All right. Now, let's say that we've got a scenario where we have an output that's only going to be on certain days of the week. So it's got a time schedule, but it's only on certain days of the week. So for that scenario, we can add the day of week function to the string of function blocks for time and date compare. All right. So again, I've hard coded this particular function block. But as you can see, I've designated that Monday through Friday, we are going to pass power flow. So this would be a scenario where I'm looking for a typical operation that's a Monday through Friday in the Western world type operation. Of course, in different countries, you have different days in which businesses are typically closed. It's not always Monday through Friday, but that's what I've shown in this particular example. So in this case, zone 2, the zone 2 output, is going to be on between the hours of 7:30 a.m. to 7:30 p.m., but only Monday through Friday because of the logic we've shown here. Okay, next, let's go ahead and talk about how we might isolate a particular date. Now, there's a variety of ways we could do this. I'm going to show you the way you would do this using the time and date compare function. So in this particular rung, we're going to flag whether it is the New Year's holiday of January 1st, pretty much any year. So let's see how that works. So we started with the start and end year. So in this scenario, I've basically said between 2023 and 2099, through any of those years, we're going to go ahead and pass power flow. Now, you might do this for a holiday or a date that doesn't change from year to year. So that might be a scenario you use where you have a range of years here. So that's what I've done for this particular function block. And then in series with that, for the month of year function block, I've identified strictly January. So again, I've hard-coded it to just January, all right, where we pass power flow. And then in terms of the day of the month, of the 31 different choices, I've hard-coded just the first. So we'll obviously be passing power flow any of the years between 2023 and 2099 on the first month or January and the first day or January 1st. And then we'll flag a coil that says New Year's holiday. Okay, so if we do a quick debug on this scenario here, we'll take a look. Now, as I'm recording this, it is currently after 7:30, so we should have Zone 1 and Zone 2 both on, because not only is it after 7:30 and before 7:30 p.m., but also I'm recording this on a Friday, so we do have power flow through our day of the week. So again, we have Zone 1 and Zone 2, and I'm recording this in June, so it's obviously not January 1st, so my New Year's holiday bit is not on. Okay, so that's a quick look at the time and date compare functions. We'll get a little more in-depth into these a little bit later when I review the scheduler. Let's move on and talk about scheduler. So what is a scheduler function? So a scheduler function is used to set time and date parameters for the purposes of control. Okay, and you may be controlling an individual output, like a light or a heater, or you could be controlling an entire machine function. Now, schedulers are most often used in building automation type applications and lighting control, but they're definitely not exclusive to those particular industries. As an example, schedulers also have their place in machine control. For instance, let's say you have a piece of equipment which features an oven that needs to warm up before you can start production. Well, you may want to automatically schedule the scheduling of that warm-up process, and so a scheduler function could be valuable in that application as well. So there's lots of different applications where schedulers come into play. So what are some key components of a scheduler? If you're going to design a scheduler, what are some components that are going to make it effective? Well, first of all, you're probably going to want to be able to set the type of operation or the type of a time-based schedule that particular device or apparatus needs to follow. In other words, is it a daily type schedule where it's operating 365, for instance? Or is it a weekly type schedule where it's operating only on certain days of the week? You're going to want to have the capability of setting days of operation. So in those scenarios where you're operating it weekly, only on certain days, you need to be able to specify those days. Of course, you need to be able to set the hours of operation for anything that isn't running just 24/7, of course. And you need to be able to handle exceptions, things like special dates when, the system isn't running, maybe holidays or off periods. And also, you need to have the capability of overriding the controls. In other words, if the plan is nobody's going to be working on, New Year's Day, and then you're behind on production, and now that needs to be overridden, that needs to be taken into account either within the scheduler itself or, of course, in the control scheme outside of the scheduler. Now let's take a look at a demo that I put together that can show you an example of a scheduler. So it's got a fairly straightforward zone control, and it's got a little bit more sophisticated kind of holiday type control. So we'll take a look at that next. Okay, let's start out on the bench. All right, so just have a simple main menu here where we have a 4-zone scheduler that I'm demonstrating here. We've got zone configuration. We've got a way of configuring holidays, and we have a set clock function. So let's go ahead and review those with you first. Let's start with the set clock function, because you can certainly build your own set clock screen in Cscape, or you can take advantage of the built-in set time and date menu item that is available in the system menu. So that's what I did in this case. So when I press the set clock button, you can see it immediately jumps to the place in the system menu where the real-time clock and the date are set. Okay, and I didn't have to build this screen. I'm just taking advantage of the one that's already built in, and the customer didn't have to hit the system button and navigate to it or anything like that. So the way that works is this. In the system registers, you have a sysreg type variable that's been pre-created for you, and it shows you, as a matter of course, it shows you the system menu screen number that you're on at any given time. So most of the time, of course, it's showing 0 because you're not on the system menu. But if you're on the main menu, it'll show a 1. And if you're navigating to one of the other screens, it'll show whatever that screen number is. Now, I went ahead and monitored that variable, navigated to the time and date menu area, and then saw that it had an item number or a value of 10. And so I just put some simple logic in that said when I press that button, then it will load a 10 into sysreg, and it'll take me to this screen. And then I can go ahead and make any changes that I want to time and date. All right, and then when I press escape, it goes right back to wherever I was when I hit that button. So it can be a useful feature to take advantage of. All right, let's start with the zone configuration that I've pre-configured here. Okay, so what we have here is a 4-zone system, all right, where we have the ability to configure a name for the zone. That's obviously useful when you're trying to, remember what it is that this zone is controlling. I've configured this first zone for offices just by typing it in through an ASCII field. I've got a selector here between daily and weekly operations. So with daily operation, it operates the same time every day, regardless of day of the week, for instance. With weekly operation, it only operates certain days of the week. And I've created start and end times, hour and minute. Now you'll notice I'm handling these as separate variables, and that's because the time and date compare blocks handle the hour and minute for the start and hour and minute for the end as separate variables. So I went ahead and made those separate data fields on the screen. That just made it easier to incorporate. And then each of these particular push buttons that are not momentary but are maintained, or toggle switches, those are tied to individual bits within a register or variable that's taking care of the days of the week. And then you'll also notice that I have a follow holiday schedule toggle. Okay, so I can determine or configure for each of the zones, does this zone follow a holiday schedule if it is a holiday, or does it not? Okay, so in this case, I've set that flag to yes for this particular case. And then I've also got an indicator that shows at any given time if that output is on or not. And of course, I've also got an indicator of what the current time and date is exactly. So the only thing that's not really incorporated in this is an override. So I probably would add just an override button in here that would allow me to, either disable this particular zone schedule or manually override the output or whatever the case may be. But of course, that can be handled outside of the scheduler as well. But it's just something you have to handle in your application. Okay, so this is zone 1 for the offices operating from 7 a.m. to 7 p.m. I have zone 2 configured, which is a production area, again, weekly, Monday through Friday from 6:30 to 11:30 p.m. I've also got a loading dock, which is configured with its own hours, but still a Monday through Friday operation. And then I've got zone 4 that isn't yet configured. So I thought I would go ahead and configure that for you. And let's configure this as, let's say, the grounds. Okay, so that would be primarily outdoor lighting. All right, so I'm going to go ahead and type in grounds here. And I'm just using the ASCII keypad that pops up automatically when I have an ASCII type data field. But for this one, for the grounds, it's not going to be dependent on holidays or even days of the week. We're going to make it a daily schedule, which is the default. We're not going to hit the holiday schedule. And we're going to change this, let's say, where it turns on at, let's say, 7 p.m., which is 1900, and it turns off at 7 a.m. Okay, so effectively, the lights are going to be on between the hours of 7 p.m. and 7 a.m. Now, of course, with a outdoor application, you're going to want to incorporate things like sensors for daylight and maybe changes to, if you don't have daylight sensors, you may want to incorporate the differences in the length of the sunlight depending on your geographic location and the time of the year and those sorts of things. But this is just a relatively simple implementation of zone control here. Now, you can also see that because at the time I recorded this, we're not between 7 p.m. and 7 a.m., that this particular output is off. So the grounds outdoor lights are off in this scenario. Okay, so that is the zone control, fairly simple, that I've incorporated here. And I'll show you in Cscape some of the tricks of how I performed this particular control. All right, let's go back to the home menu now. And let's take a look at how I've set up configuring holidays. All right, so I'm going to go do that. Now this isn't an absolute necessity for a scheduler, but it is a function that makes it more useful, obviously, because holidays do occur. So what we have here is I have incorporated up to 16 holidays that can be configured. And then, of course, when a holiday occurs, I'll show you its impact on the control scheme when I show you the Cscape portion of the display. So the user can navigate between holiday numbers all the way from 1 to 16. Okay, let's start with number 1 here. Now, they don't have to be in date order or anything like that. You just gives a method for you to add the holidays that a particular business or what have you is observing. Now, let's start with a holiday that recurs, the one we talked about in our simple demo earlier, and that is January 1st, or New Year's Day. So that's the same regardless of what year you are. It's a fixed holiday. So I've got the starting year, obviously with a range. I've set it for January 1st. And so regardless of year, every January 1st, that is going to happen. Now, if this was a floating holiday, we would probably just set it to a specific year, and I'll cover a floating holiday in a minute. Now, the way this is configured, once you've set, your name for the holiday and all these parameters here, you need to remember to store it. Okay, now I haven't changed anything, so I don't have to hit the store button, but I'll just hit it again anyway. And that store button actually takes this data and stores it away. So if you forget the store button, you're not going to be able to recall that holiday later on, of course. Okay, so we've got another holiday configured here, in this case, Martin Luther King Day, which is observed by more and more businesses these days. Now, this is a floating holiday. It's one of the Mondays in January, so it changes every year. So I've got this configured just for 2023, in which it's January 16th. The third holiday is Good Friday. Again, some businesses observe this, some don't. You'd plug in the ones that you'd observe for your business. This year, again, it's floating, so April the 7th is for this year. Now let's put in the next holiday, which in the United States at least is Memorial Day. So I'm going to go ahead and type in the name of the holiday, okay, using, again, the built-in keypad that just pops up automatically because I've got a ASCII type data field that I've got here. Oh, I got to use the backspace key there. So Memorial Day, enter. All right. Now this again is a floating holiday. It isn't the same date every year. So I'm going to make this for 2023 only. Okay. All right. And it is in May, and this year it is the 29th. All right, now, if I forget to hit this store button, I'm going to lose what I've already configured. So I need to hit the store button. All right, and I went ahead and configured that particular holiday. Okay, so that'll give you an idea. Of course, to finish up this task, you'd finish up all the rest of the holidays that needed to be configured for a given year. And then every year, you need to go through and fix all the floating holidays by changing the year and the date for that particular year. But the fixed holidays like July 4th and January 1st in the US at least, those you wouldn't need to change every year. Okay, so this is a quick look at a simple, relatively simple at least, scheduler demo that I put together with 4 zones of control and then a little more sophisticated holiday capability. All right, next we'll take a look at the Cscape program for the scheduler that I just showed you. All right, now the first thing I'm going to show you is I'm going to go actually into the hardware configuration, and I'll show you a hint that I would have if you've got a way of connecting to the internet with your machine or maybe to a local server in your plant. where you have an NTP server available to you. So in my application here, I'm accessing the internet through a gateway, and I've specified a DNS server. And in my bench application, I'm actually going to time.nist.gov so that the OCS can regularly have its real-time clock updated with the proper time. So that's a great way for the OCS to keep basically completely accurate time, because it's going to be checking periodically, not every second, but it'll be checking periodically and updating its clock with the appropriate time. So it'll check at least once a day, I believe, if not more often than that, but not often enough where it'll get in trouble by pinging that too often. So again, it doesn't have to be an internet-based time server. It can also be one in your own plant that might be available so you don't have to exit the facility. Okay, so that's just a hint for you there. All right, let's start by taking a look at how I've organized this program. So over here in the main loop modules, there's nothing going on in main. You can see that's pretty much blank. I left that empty for anybody that wanted to kind of use it for themselves. We've got each zone has its own section of logic, and this is pretty straightforward logic, not a whole lot to it. So effectively, you can select for every zone whether it is doing daily control or weekly control. So if it's doing daily control, it doesn't matter what day of the week it is. Basically, it just matters what time of day it is. So this would be for something like the outdoor zone, where it's going to be based on time, let's say, regardless of whether it's a holiday or not, regardless of what day of the week it is, all those sorts of things, okay? So even though holidays isn't really incorporated in this yet, I'll show you at the bottom where the holidays come in. Okay, so for zone 1, we've got daily operation and we've got weekly operation where day of the week comes into play. And then down here, we have some simple logic that basically says if either our daily output or our weekly output is on, telling us that that output should be on, the zone output should be on. If the holiday flag is not set, in other words, if this zone doesn't care about holidays, the holiday flag will have no impact on the actual output of the device. But if the holiday flag is on, it will prevent the output from being on if it is a holiday today. But if it's not a holiday today, it can also pass power flow as well. So, and that's the identical logic I have for each of the 4 zones. Now, I mentioned a couple times already, I have not incorporated overrides into this. So you'd have to separately handle overrides for, let's say, you weren't planning on working on January 1st, but you have to work on January 1st, so you need to override the system. Okay, so that's the zone control I did. Pretty straightforward. Let's take a quick look at the screens for zone control. All right, we'll just look at the zone 1 here. This is a fixed array, byte array that's used for the name. Now there's 20 characters or 10 elements to the array. This is our 16-bit selector, which is either just has a value of 0 or 1, okay, depending on which of the two is set, and that's how you determine whether you're on a weekly or a daily type schedule. Of course, here's the start time and end times that get fed into those variables that get fed into the function blocks. This is our holiday flag, whether it's impacted or not, and these are the individual bits within the day of the week for that zone register. Remember, the lower 7 bits of this day of the week register are effectively correlating to Sunday, which is day 1, through Saturday, which is day 7. Okay, so that's how we did that. And then these are those time data objects that we have here to display time and date. We're displaying the day of the week here using a text table. And here we've just got a bit that turns on if it is a holiday today. And I'll show you how we determine if it's a holiday or not later on. Okay, so that is our simple zone control portion of our logic. All right, next let's take a look at the holiday control. Now this is a little more sophisticated, and I guess we'll start on one of the screens here, and we'll navigate to our holiday configuration screen. Okay, so what I've created here is I've created an array, or actually multiple arrays, that have a dimension of 16. So there are 16 different elements in the array, okay? We've got 16 different names, 16 different start years, end years, the month and the date variables also have 16, are also arrays of 16. And the way this works is as follows. So I got a little bit clever with this. So the 0 element, okay, so the 0 element, so the name sub-0, start year sub-0, end year sub-0, month sub-0, date sub-0, the 0 element is actually used to display on the screen a holiday that can be edited, all right? But it's not one of the holidays that can be used. So it's an array with a dimension of 16, so 0 to 15, but only holidays 1 through 15 can actually be saved. So if I said there were 16 holidays supported, it's really 15 holidays supported, okay? So, but holiday sub-0 is the one that's displayed on the screen. And then after the user effectively manipulates that particular data on the screen, then the 0 array data will be copied over to the indexed array that's indicated here. So if he is showing number 7 here, and he's editing number 7, he's in reality editing the 0 array data. And then when he hits the store, it copies from index 0 to index 7 in that case. So we're getting a little bit clever here, but there's nothing that complicated there, just something to be aware of, all right? And this code is well documented, so I'm not going to spend a ton of time on it today, but if you have further questions, feel free to enter them in the comment section. All right, so next, let me show you the holiday section of the code, and it's in, I think, 3 different parts. So the first thing we're doing is every day at midnight, we're calling a subroutine to check to see if today is a holiday. Because remember, holidays are, as far as I program them here, are 24-hour periods. So therefore, you only need to check once a day to see if it's a holiday or not. And it calls a subroutine called holiday today. And what this subroutine does is effectively runs through a loop where it goes through each of the 15 different stored holiday datas, and one by one pulls out the individual data and sees if the data matches. Does the year, start and end, month, and day, does it match? Do any of those holidays match today's date? If they do, it's going to set a flag that says, yep, today is a holiday. And then as soon as it's gone through and either found a holiday or checked all 15 of the potential holidays, it'll be done and it'll return from the subroutine and go back to the holidays area here. So that's how we determine if today is a holiday or not. Now, we've also got some logic in here for displaying holiday data on the screen. So that screen I showed you earlier. So this is where, depending on which particular holiday number is selected by the user through the increment and decrement buttons, it's going to load up the start and end year, the month, the day and date data, all that sort of thing that is already stored, if any, for that holiday number. It's going to load that into the index 0 that's displayed on the screen. And then the operator can go ahead and manipulate any way they want. And if they hit the store button, then it's going to take all the data they've modified, which is index 0, and it's going to move it into the index number that they had previously selected, and it's going to store it away. So that's how that works. Okay, and again, this is all pretty well documented. So if you have any additional questions, feel free to give us the questions in the comment section. Now, finally, I've got a little set time routine here, and that's the one I already described to you during the bench part of the demo, and that is when you press that set time push button on the screen, on that first page there, it's going to load a 10 into the sys screen system register, which effectively goes to system register screen 10, or system menu screen 10, I should say, which happens to be the time and date screen. Okay, so that's a look at this particular scheduler demo. Hopefully you found that informative and it's useful either to use kind of as the basis for your own scheduler or to give you ideas on how to do your own scheduler. Let's go ahead and wrap up our topic. Okay, as I mentioned, Cscape incorporates time and date compare functions as part of their standard command set. So no requirement for any special user-defined function blocks. It's built right in. Now, these time and date compare functions are very useful for real-time clock-based control and for building a scheduler capability into your equipment. Now, schedulers, should you create them, should have the ability to deal with time and date parameters, configuring whether a device is operating on a daily or weekly type operation, and it should be able to handle exceptions, notably holidays and potentially manual overrides. Now, of course, manual overrides could be outside of the scope of the scheduler, but they should be handled somehow in the application. Okay, this is the point in the program where I remind you that we're here every Tuesday at 2 o'clock, whether it's fully live or whether it's pre-recorded like this week. But in either case, we will be streaming live the new video every week with someone standing by to answer your questions in the chat section. If you're watching on replay, like a lot of you do, we would love to see your comments and questions in the comment section, and we'll reply to those just as soon as we can. Okay, we're celebrating 10 years of Horner lighting products. Check out the Horner lighting videos alongside our automation content on the Horner YouTube channel. All right, now don't miss training opportunities in July and August for basic and advanced training. We still have some slots available. And next week, we're going to be covering a topic, Modbus variable conversion in enhanced IEC 61131. Now, we've covered IEC and Modbus before, but this week, or this next week, I should say, we'll be covering some intricacies in terms of how enhanced IEC can deal with the fact that Modbus is very much a memory mapped type protocol with very specific type capabilities or requirements, and IEC, especially enhanced IEC, doesn't really have any memory mapping type concept at all. So how do you solve that? Well, it's definitely solvable, and we'll show you how to do it next week. If you haven't subscribed to our channel, don't hesitate. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. All right. So until next week, when we talk about enhanced IEC and Modbus, let's all get out there and do us some good.